When a loss of cell cycle control, or when your cells aren't responding to whatever the control systems are supposed to be, checkpoints aren't working, whatever it is, that is when you get cancer. And so I kind of have a checklist of things to go through here, but if you were to look at a cancer cell, first of all, some properties of cancer cells. So I'm going to jump to this property thing here. Some properties. If you have a cancer cell, the one set of properties is those the anchorage dependence and the density dependence is not seen, and you can see that down here with this these cells growing in a petri dish. If you have a group of cells would normally stop dividing at one layer of cells. Cancer cells don't do that. They'll stack up on top of each other, and they've lost that control system that says, hey, if there's a limit to resources, we're not going to divide. They just keep dividing. Okay. Same thing with the anchorage dependence. If you put them a solution of cancer cells, suspend them in solution, they're just going to keep dividing. As long as the nutrition's there, they're going to keep dividing, keep dividing, keep dividing. So other things. Yeah, pretty much all the control systems. Here's another one. If you take a normal set of cells and put them in a petri dish and have them start to divide, they'll divide, I think, up to like 50 times, and then they stop. It's like they meet an end to their limit, their capacity to divide. If you do cancer cells, it's unlimited. It goes forever. There's actually a series of cancer cells, and we may study them later this year, but that they've been dividing since the 50s, and they just keep taking a couple cells off of the growth and putting it into a new petri dish, let it grow for a while, take a couple cells off, and since the 50s, and they just keep dividing and dividing and dividing, and there seems to be no limit to it whatsoever. Okay, so that's cancer cells. They have these weird set of properties. Just some terminology. A bunch of times this year, I think we're going to, especially in this unit on genetics, we're going to get into talking about cancer, and so it's terminology that you'll get along the way, or things that you may have heard from family members that you that have experienced cancer. First of all, the way you get cancer, and this is called transformation here, when a cell goes from being a normal cell to being a cancerous cell, and essentially what happens is you would have a normal cell that's going to go through mitosis, go through the cell cycle, and sometime during that cell cycle, probably during synthesis, but it could have been anywhere, there's going to be something that's going to mess up the genetic material, and we'll get to details on this in future chapters, but something will mess up the genetic material. So maybe it was ultraviolet radiation, okay? Messed up the genetic material, and when this thing divides, chances are, as it divides the two cells, one of them is going to get an okay version of the genome, and the other one, could be a check plus, the other one's going to get the genome that has the screw up in it. And if that screw up happens to have something to do with the control system, cell cycle control, then all of a sudden the cell potentially could become cancer. Okay. At this point, most of the time, your body actually has a series of cells called T cells, and those T cells will usually find these things and destroy them. So there's a decent chance that at some point in your life you'll get cancer, as cells are the potential for cancer, but your body will actually destroy it. It'll recognize some differences in there and destroy it before it becomes a problem. So that's transformation, a cell going from being a normal cell to one that potentially will be cancer. Okay. Then once you get cells that have this problem with, like, they just keep dividing and nothing is checking them, that can take two forms. One is the form of something called a benign tumor. I actually had a benign tumor when I was in college. It was kind of a crazy story, but I find this lump underneath, it was in my chest, the side of my chest, and underneath my arm. And I'm like, what is this? The trainer says, hey, you got to go get it checked out by a doctor. The doctor goes, we don't know what it is. All we know is it's a growth. And the last thing I'm thinking is this could be cancer. But anyway, so they take, they surgically remove this thing, do a bunch of tests, and find out that it was a growth that was not actively growing. It was not invading anything, and it was just kind of unto its own self, separated from the rest of my body, just inside of it. So they call that a benign tumor. It is a growth, but it's not causing any problems, and it's just like not the design of it. Okay, so whatever the mutations were, this thing is kind of staying to itself. Versus if you get a tumor called a malignant tumor, then a malignant tumor is something that is starting to, as it's growing, it's starting to invade the cells around it. And there's a bunch of ways it can do that, but it's invading the cells nutritionally and a bunch of other ways, the cells that are surrounding it. And it also may be spreading, like pieces of it may be dropping off and going through the body and starting to grow somewhere else, and it's just very invasive. That they call a malignant tumor, and if you have a malignant tumor, that's when the word cancer starts to get used. You have a tumor that's invading other parts of your body, okay, whether it's locally or throughout your entire body, okay. So then metastasis is a term that would be used if you have a malignant tumor that has indeed spread to new locations. And again, the way that would happen is a cell or two would break off of the tumor, get taken by the blood or the lymph system throughout the body, and find a new spot and start dividing there. And so you get cancer at different places. That's called metastasis. Okay. Ways to deal with cancer. And I'm kind of running out of time, so I'm not going to get as detailed as I want here. But ways to deal with it. You all have heard of chemotherapy, and you've probably, most of you, heard of radiation therapy. The theory with radiation therapy is that these cells, when we had transformation happen, this cell right here, and it has this genetic mess up in it, that means that for some reason this cell doesn't do a good job of fixing its genetic makeups. So one theory is, if this thing gets genetically screwed up easily, then let's try to genetically screw it up to the point that it dies. And so radiation, people, they know that radiation causes mutations genetically, so they will zap an area where a tumor is, a malignant tumor is, with radiation, with the hopes of killing the malignant cells because they don't do a good job of fixing DNA screw-ups. Okay, and the others of your cells, they might die, some of them, but your other cells normally do a good job of fixing any genetic screw-ups that happen. Okay, then the final thing here, chemotherapy, then is taking chemicals and putting them into the entire body, and those chemicals specialize basically in stopping the cell cycle. Okay, so if there's any cell that is actively going through mitosis or even synthesis sometimes, then these drugs will basically stop that cell from progressing. Okay, which works really well for the cancer cells because they're always actively dividing, so it'll kill a lot of those cancer cells, or at least stop them from moving forward. The problem is that it also hurts a lot of your other cells. Okay, and in the process of hurting a lot of your other cells, it will really take a toll on your body. So like the reason hair falls out for some types of chemotherapy is because it may kill the cells that divide often, that are going through mitosis in your hair follicles, because that's a location where there's a lot. People get really bad stomach illness, very nauseated and things like that, and that's because they tend to, these drugs tend to kill the cells that are on the lining of your intestines, and they go through division a lot. So if they happen to be in division, when you get one of these drugs, it'll stop those. And so there's a lot of side effects to the chemotherapy for sure, but because cancer cells are dividing, it makes sense. Let's put a drug in that's going to stop cells from dividing. So we're going to end that discussion there, and I believe that ends this chapter. So we'll see you in class.